Okay, so we're doing defects of human eye. So there are two defects. The first one is being long-sighted. Long-sightedness would mean that the person can easily see far objects, right? But he or she is unable to see the objects that are placed close to them. So this is what they are able to do, and they have a problem looking at objects very close to them, right? So observing objects close to them. So we're going to draw all these light ray diagrams in terms of P1 and P2 questions, how the examiner gives you the question for that or regarding that, and then we're going to finalize how to correct that. So all three things will be a part of you. You need to understand what their capability is, you need to understand what their problem is, and you need to understand whatever problem they may have, how to correct that problem. Okay, so let's make the eyeball that we have. So this is how the examiner will give you the eyeball, and they will show you a lens at the front where the expected lens of the human eyes do exist. Okay, so first we're going to identify the problem, right? Sorry, not the problem, but the ability, what they can do. So first we will draw the light ray diagram for what they can do, ability. Then we can write down, we will draw the ray diagrams for the problem they have, and then we're going to provide the solution to that problem with using glasses and lenses and so on and so forth. So what they can do easily is that they can see objects that are far away from them. So objects that are actually far away, they provide light rays that are parallel to each other. Our assumption is that anything coming from far away, from an infinite distance, considering the size of the eyeball, it generally produces parallel light rays. Now, just to give you a perspective about that, if this is my sun's surface and this is the earth, although we know that the light of the sun is basically diverging outwards like this, but when these light rays actually do reach the earth, now since the earth is so small in comparison to the sun itself, it looks like it gives us the perception that the light rays actually reaching the earth are almost parallel to each other. They are almost parallel to each other. They give us this impression. So same idea is being implemented over here, that the objects that are placed far away have parallel light rays. So this person who is long-sighted can easily see this and easily focus these light rays on the retina over here somewhere like this. Now one thing I would like to remind you over here, that the retina, if you go in biology or if you're doing O levels biology, you will find that the retina is somewhere along this line where the optic nerve starts. You're not going to do that. We are not following that. Retina in physics will be at the center of the eyeball. So this is where the retina is located. So if you are required to complete this diagram, you will meet the light rays at the approximate center of the eyeball on this side. Just by looking at with the eye, you don't need to make any measurements. You're just going to observe this with the eyes, that where does the center of the lens approximately appears to act, or wherever the principal axis is, right? Okay, now this is what they can do. Now we're going to move towards the problem, what they can't do. So they can observe far-sighted objects or far away objects, but they can't focus on the close objects. So objects that are placed close to them, they generally produce light rays that are diverging, and of course try to make sure that these light rays are actually passing through the lens. Because I'm drawing them freehand, I'm unable to do that properly. They are supposed to pass to the edges of the lens. So this object is close and its rays are diverging, right? Far away object, the rays are parallel, and you are supposed to know that information and keep that in your memory. And now what this person will not be able to do is focus them on the retina. So you will see that it looks like that it is unable to do so. So expected location of the light or the diagram is actually outside the eyeball. I'm drawing this with dotted lines because this is not real. This is not where the light ray is going to be. It is just going to fail to focus the light ray on the retina. So the problem is sometimes mentioned in the exam as these words. Let me write down those words. He will say that the image, about the image, this is my image location, although it's not on the retina, so it will not be focused. So he will use the words about the image that it is outside the eyeball or outside the eye, right? Or he will say it is behind the retina. Just a few words that he uses to describe where the image is actually being formed. Okay, so next we have to find out a solution for this problem, and let me clear this out and draw that again. So we need to find out a solution for this problem. So again, the person does not have any problem with observing far-sighted objects. He has a problem with close objects. So we will place the close object's light ray with it or on it, because this is what we're trying to focus, and if we can successfully do that, we can sort out all the other problems. So for this problem, we will place a convex lens as in its glasses, right? Why? Because if I realize, or if I try to understand this properly, what's happening over here is that the person is unable to focus them more on the retina. He is unable to converge them. He is unable to focus them even more than his lens is already capable of doing so. So what we are going to do, we're going to provide it with a little help from the outside by focusing the light rays a bit more before they enter the lens. Now when they do, the rest of the work can be done by the lens of the person, him or herself. So of course, when you go to the optician, he gives you the glasses or lenses of the appropriate powers, like 1.25, 1.0, 0.75. They have 2 to 3 other factors to calculate or to look at, but this is what they're actually looking at. They are trying to adjust the power of the lens so that you can see things clearly. Now this is what the solution would be: to place a convex lens or a converging lens. Both words would be acceptable. A converging lens, and you will find this problem or long-sighted problem generally in old people. Maybe your grandparents, they may require glasses to read the newspaper because they can identify you coming across the hallway, because from you the light rays are coming parallel to each other. You are a distant object at that point. But when they are about to study something, when they're about to look at their phones, when they're about to look something at very close distance, this is the diagram that they're actually experiencing at those instants, and they can't do that. So this is the problem that they face, and when you do give them the reading glasses, this is the lens that is installed in those reading glasses, which enables them to see a little bit better. Okay, so this is what a long-sighted person goes through, and this is all the mechanism for it. Now, and these 3 diagrams will be asked from you in P1 and P2. It could be possibility that he asks you what they can see. It could be possible they may ask you what they can't do. That would be the problem. And they can ask you what will be the diagram of the solution. So always remember that we have to focus the light rays. The target is to focus the light rays or the retina one way or the other. This is the end goal for any person, for anyone who is actually designing the glasses or the power of the glasses. Okay, and the power of the lens or the power of the glasses, this is an entirely different topic, not a part of your course. Okay, now we move towards the person who is short-sighted. So we move towards short-sightedness. Again, the ability of the person that he can see close objects clearly, but the problem that they face is that they cannot see faraway objects, and you will face these problems in the younger generation. For example, if you have your class fellows, and for example, if you have an older brother or an older sister or anyone who has glasses of your age group, they can see their mobile phones, their laptops, their notebooks very clearly, but they can't see things at the distance. For example, if they're standing at a point and they have to look across the hall, across the road, or just look at the number plates of a car that is slightly far away from them, they may be unable to do so. They will look at a blurry image. Now, this is a problem that they may face. Now, this is again a gross generalization, right? It's just an average generalization. It doesn't happen with everyone, but generally this is what's happening, or this is what the trend is. So again, we draw three possible cases in which we are going to identify their ability, their problem, and the solution to that problem. So first we have their ability, what they can successfully do, then the problem that they face, and then the solution to that problem. Okay, so these are the eyeballs of the respective person. And the small lens that is inside our eyes already placed over there. Again, if you look at the ability, they are short-sighted, so they can look at closer objects. And I know as a student that closer objects emit light rays that are diverging away from each other. So it is good enough to converge them at a single point at this location on the retina. So this is what they can do, right? So this is a close object and diverging rays are being observed. Diverging rays, right? And this is our retina that we want focused image on. Now let's look at the problem that they do face. So if they can look at objects that are close to them, they are unable to look at the objects that are far away. So objects that are far away produce parallel light rays. Sorry, this is a bit too far away. That should pass from the lens. Keep that in mind. It should pass from the lens, right? So this is a far away object, far away, and parallel light rays. Parallel rays will be the condition, or will be the indication of that. But this time around, they will focus the image in such a way that the intersection point will form before anything else. So over here, how the examiner defines the situation, this is where the image is being formed by mistake. It's not being formed on the retina. So he will describe the situation in something like this. He will say that the image formed before retina, or before reaching the retina, right? Okay, so these are just words used by the examiner to describe the situation. You may also use them as your own answers for a P2 question. Now let's look at the solution to the problem. The way I see it over here, we can identify that it is the lens of this person in the eyes is trying to focus the image a bit too much. It has caused too much convergence. Let's look at over here. You see, one lens is trying to focus the light rays like this one, right? But there is another lens that tries to do something different than that. It tries, for the same light rays, it tries to focus them even before the previous lens. So the blue lens, or the lens representing the blue lines, is trying to focus, it's trying to converge the light rays a bit too much, or it's doing that a bit too much, right? It's too powerful for the certain situation. So that's why the light rays are bending even before they could reach the retina of the eyes. So since it is too much bending, it is too much convergence, what I would identify this as, that what I need to do is I need to place a diverging lens so that the light rays may be diverged before they reach the eye. Deliberately, we are doing this deliberately to compensate for the effect that the lens of the person is already doing. the lens of the person is converging them too much. What we want to do and how we counter that is that we deliberately, on our own, diverge them, knowing the fact that the lens of the person will be too powerful and will try to converge them too much. So we provide the compensation on the outer side and we negate the effect of the eye of the person which is trying to do it with a bit more strength, you can say. It's doing it a bit more. So again, the goal of this will be to focus the image on the retina. I'm reminding you this point one more time, that if you are a biology student or O-levels or IGCSE biology student, you will find that the retina is somewhere over here near the optic fiber, near the optic, not the fiber, but the optic nerve that we have. You will not be considering that as a retina. We will be considering the retina at the approximate midpoint of the lens of the person. So this is how we draw the diagram, right? So what lens are we using over here? We're using a concave lens or a diverging lens to correct the problem that this person faces. And again, this problem is generally faced by young people. They can successfully see the object placed very close to them, but they're unable to see objects that are placed very far away from them. Okay, so